Hey everybody, this is Mr. Munson, and we are looking at Unit 1 still. We're going to be doing two sections in this video, 1.2, which is segment length, and 1.3, which is distance. Okay, let's go ahead and get started. But before we get started, I have some more vocabulary words that I want you to get done right away. So go ahead and pull out your yellow sheet. If you need to, put me on pause. Pull out your yellow sheets or your vocabulary sheets that you have for this section, and let's add a couple more. So if you've done and finished the video from 1.0 to 1.1, you have coplanar on the second sheet already done. That's the one right above the one you can see now. And this next one I want to do is called the postulate. Okay? Remember, you're going to write it on the back here. Oops. It's having some fun there. And so it's, you can write it on you're going to write it on the back there. Writing it in this spot here where it's blank is up to you. Okay? So postulate, or something else called an axiom, you might see it spoken in that word, is just basically an accepted statement. You know, through any 2 points, there's exactly one line. I don't have to, prove that. That's absolutely true. Okay, and it kind of in addition to that is the word theorem. And a theorem is a conjecture that isn't automatically accepted as being true, but it has been proven to be true. An example of that is the Pythagorean Theorem, which is a squared plus b squared plus c squared, and that's just a relationship between the sides of a right triangle. That's been proven to be true. And you go online and type in Pythagorean Theorem proofs, and there's all kinds of ones out there that you can watch people do. Next one's intersecting lines. Intersecting lines are two lines that intercept. That's as easy as you can be said. Two lines always meet at a point if they're two distinct lines, meaning they're two different lines, okay? Now, I just want to note that common notation for lines, sometimes we use 2 points and say, hey, that line AB, and we'd write it as AB with a line above it, okay? Or we can say a little cursive R or lowercase s or T or whatever the letter is, and we can use those single letters to designate a line. Remember to be writing these on the back, okay? Intersecting planes, that's basically two planes that meet. When two planes, like here we have a kind of an orange and a blue, when they meet, they always meet in a line, okay? So in this case, ST is the line of intersection for plane R and plane W, okay? So let's go ahead and put that in here. Here's the symbols for a plane, a square that's kind of leaning over. So plane W and plane R intersect at line ST. All right, we're going to come back to our vocabulary here in just a second. Let's go ahead and get started with some notes. Segmentation is really an easy concept. We're going to go through this rather quickly. It just basically says that two segments can be added together to create longer segments. So here we have two segments, AB and BC, and they're put together and they're forming a straight segment. Okay. Now what I want to note is in green there, you'll see that I have an A and a B written above that segment. That AB, when it has nothing above it, represents the words measure of AB. Okay? And so the BC stands for the measure of BC. They represent an unknown number. So here's an equation. Notice I have AB plus BC equals AC. The smaller segment AB plus the smaller segment BC certainly equals the entire length. So this next equation I just wrote does not make sense at all. The notation is very important, okay? AB with a line above it is the name of that segment, like Fred, John, or whatever. So when I write this thing above it, I'm talking about the name. So to say the name plus another name equals some other name, some line AC, it doesn't make sense at all. So this is incorrect notation. Notation is very important. Just like you wouldn't walk in and use an exclamation point for a comma or a question mark in English, there's certain notation that we use. Same is true as math. All right, so let's take a look at this example. You just work it with me. Basically, I have two segments that can be added together. It tells me that the length and the information, the measurement of E to G is 59 inches, millimeters, doesn't matter. And then it wants me to find X and also tell them how long is EF. So the process is easy. We're going to set up an equation, find X, then we'll just take that X and plug it in for the expression that makes up EF. That's simple. Let's work together on it. Now, hopefully you understand this statement. It just says that the first segment plus the second segment equals the whole thing. And from this point on, it's simple algebra. I combined the x's on the left-hand side together and simplified the equation. Subtracted or added 13 to both sides. And now I've found x. Now, the other part they want me to work on is to find EF. So I'm sorry, I just realized I forgot to draw my line down this side to create the place to write any equations or questions. I apologize for that. So I'm just going to continue over here. And so now I found what x equals. Now I need to find out what EF is. So EF equals. And so now it's just a matter of taking that x equals 6 and plugging it in for the expression of EF. So looking back at the drawing, I can see EF is expressed with 8x minus 14. So now I'll take that 6 and plug it in. And after simplifying, I find that EF is equal to 34. So I'll just circle that and have it as my answer. Now, the beauty of having an electronic board is that I can just stick the stuff over anywhere I want. But I want to keep it on the screen so that you can watch as we do the try it problem. Okay, now it's time for your try it problem. I've scooted everything over to the left so it's still there so you can see it. Certainly it's in your notes. But let's go ahead and work on this problem on your own. I need to find JK and KL, which is exactly like the problem before, just different letters. Remember to find the X and then just plug it in. Put me on pause, come back and check your work. All right, welcome back. Here's my equation, my setup to find X equals 9. A lot of students stop there. Remember, that's not the question. I wasn't asking you for the X. I have to find the X to find the answer, which is what is JK and KL. Okay, so let's move on. And there's my JK. I just plugged in the 9 to the expression. I wrote the equation, plugged in the expression or the X equals 9, and found what JK is. And there's KL. Okay. All right, fantastic. Now let's move on. This problem is our try it problem. I want to show you something where we're going. In the next unit, we're now in Unit 1. In Unit 2, we're going to start dealing with circles. And what I want you to know is you're going to have this exact same problem, but we're going to add a circle to it. Just like that. Does that change anything? It doesn't. It's just a circle. It didn't expand the segment. It didn't do anything to it. This problem is done the exact same way. You know, we'll have the same exact equation used. The whole thing added, the two pieces added together equal one segment worth 120 units, okay? It doesn't change one bit, just that I added a circle. And it won't change anything if I add a line over here. It's still the same information for the same thing, okay? So when we get there, you just see it as I've done this before, okay? Let's move on. So two segments are said to be congruent. The word congruent, and we'll talk about that in a bit with our vocabulary, said to be congruent if their measures are the same. Since the measures of those two segments are the same, we would say that those segments are congruent. Let's look at the symbols for that. So this statement right here that's in black is saying that segment AB is congruent to segment CD. Okay, that's the symbology for segments, and in the middle there is an equal sign, a little squiggly sign above it. That represent things that are congruent. So if you take a look at these two items written in black, they say something completely different, but they're related. Okay, the first one says AB is congruent to CD. The second one, notice it's missing the bar and has an equal sign, not a congruent sign. That is read, the measure of segment AB is equal to the measure of CD. Okay? So when we're talking about things being equal, there's no thing on top saying that it's a segment or not. When we're talking about it by name, hey, this segment's congruent to that segment, you have that notation at the top. Okay, so we're given this problem here. It looks very much like the problem we've been working at, but here's the thing. It doesn't tell me how long it is from P to R like the other ones. But it does give me another clue. It says Q is a midpoint. Now, I've abbreviated the word midpoint there, MIDPT, but Q is a midpoint. A midpoint is exactly in the center of 2 points, okay? So if a Q is a midpoint, that means P, the distance from P to Q, is exactly the same as Q to R. So if I needed to find X, I'm going to have to write an equation. So let's think about that. If P to Q is the same as Q to R, the equation would look something like this. And there you have it. Okay? Now it's just from this point on, simple math. Okay? I'm not going to do that problem for you. The setup is enough to show you how you write the relationship. Q is the midpoint. It creates 2 segments. Now I want to show you some additional notation when we're talking about congruent items like this. Now I just said that since Q is a midpoint, P to Q and Q to R are the same distance. That means that they are congruent to each other, they're the same measure. The way we show that is we take and we strike a mark like that, a single mark. Sometimes it can be a double mark if we're trying to distinguish it from other marks. But when we put those 2 matching marks on those 2 pieces, it means that they're congruent. Here's another example. At the top there, you'll see a rectangle, or at least it looks like a rectangle. You see the 2 green marks are two marks. Those marks indicate that those things are congruent. The red ones indicate that those 2 pieces are congruent. And it also indicates, not because of the color, but because one's a single, one's a double, that AD and BC are not congruent. They're 2 different lengths. Okay? Okay, now it's time for you to try, see if you can create a reality of confidence here. I have a segment, or a series of segments, A, B, and BC. B is the midpoint, just like the previous problem. Set up an equation, solve for X, come back in just a few moments after putting me on pause and check your work. All right, very good. We have X equals 5, right? Now I could certainly ask you, what does AB equal? That would be a totally legit question. And if you did, then you just simply take it and plug it into the expression for AB. BC, what's that one, right? That would be another question I could ask. How about this one? AC. Just take a few seconds and see if you could actually be able to do those. You can do them on your own, whatever. But take a few seconds, just make sure. Do you have a question about that? Let's move on. All right, very good. So at this point of these notes, wherever they're at, draw a line. We're done with 1.2. I want you to take a few moments, write a summary. Okay? Now, go ahead and put this in your own words. Come back and check to see what I have, see if we want to add anything, and then we'll move on. Did you put it on pause? Because if you didn't, that's what you're supposed to do. Go. All right, so this is what I wrote. I said, in this lesson, I learned how to add smaller segments to get larger segments. I wrote equations using segment addition. You might have something slightly different or different words. No worries. I just need you to summarize what you learned. Okay, draw your bar underneath the summary, and let's get started on the next lesson. All right, here we go. We're getting ready to start into the next section, 1.3, distance in the coordinate plane. So here's an example of some of the stuff that we're going to be dealing with. Let's get into the notes. All right, so make sure you set up your notes now properly. You have the question mark, the 2 bars, all that stuff. Distance in the coordinate plane is the subject. And so here we go. Now I'm going to switch to a different scene. And what I'm getting ready to do, the blue lines that are on this page are just going to be distracting with my graphics. So as you'll see, I'm going to move to a different page, but just continue your notes on this in your note. All right, so suppose I was in the coordinate plane. I was looking at some point that was at the 8 on the coordinate plane and 24. So there's like a gap on the blue lines represent a gap of like, let's say 4 instead of a 1 that you're used to. So I want to find out the distance between 8 and 24. Real easy. Take the larger number, subtract the smaller number. It's a distance of 16. It's really quite easy. You have I'll call it x2, the x coordinate that's up higher, x2, and the smaller one, x1. And you just subtract them, okay? And that gives you that number. I'm going to look at a little bit different thing, so if you haven't taken notes on that, go ahead and draw that up real quick. And then we're moving. All right, suppose I have this problem, and this is where I'm just going to slide it up and make it a little bit larger for us. And so what we're now looking for is the distance of that red line, and it's not straight across or straight up and down. It's kind of diagonal, so we have to come up with a means of finding out the distance of that. Okay, so let's look at trying to find the distance between A and B. So let me just kind of remind you of something real quick. All right, so you're all familiar with Pythagorean Theorem. Basically, this is used in right triangles. Um, these are the legs, and this is the hypotenuse. So that translates the legs are squared and added together equal to hypotenuse. We're going to use that brilliant Pythagorean Theorem idea to find the distance of this line. If you take a look, I have a right triangle there. And so what I'm going to do is I'm going to find the distance between 7 and 10, and the distance between 1 and 5, the vertical amount, and I'm just going to plug it into the Pythagorean Theorem. Here's that side. Up here at the top is this other side. So I have this right triangle, and I'm going to try to find out what AB is by just simply using Pythagorean Theorem. Now, I don't know what AB is, so I'll just call it AB squared. No big deal. That's the next step, which is the next step there, and this should look familiar from our algebra review. We're going to take the square root of both sides. 5 ends up being over on this side. This square root, the red square root, cancels out the square and leaves me with AB. So the length of that segment in the coordinate plane which is AB, is 5 units. All right, it's time for you to try it. So again, use graph paper or something similar to it. A is 6, 2, and B is 2, 5. If you look at my graph, it doesn't look like they're in the right place, and it doesn't matter, right? I know the coordinates, and so I just plug them in. I'll put the numbers down on the x and y axis. I'll subtract the numbers, find the distance, plug in the Pythagorean Theorem, you're on your way. Okay, if you're confused right now, then you should back up, not try to attempt to do this problem. You should go ahead and back up to the example, do the example, and then come back and try to do this one on your own and build your confidence. Okay? All right, put me on pause, come back and check your work. So I'm going to put the points down with their coordinates next to them and just kind of be able to visualize what's going on. I like to circle my information to help highlight it in my mind. Lo and behold, the work that we did on this one after this point is the same as the previous problem. We end up with AB equal to 5, and we have it. Okay, so go back and review if this is complicated. Also consider writing any questions of clarity that you need over on the left-hand side of your notes. All right, so let's continue our notes. Need another page here. All right, let's talk about the distance formula real quick. I'm sorry for my lazy hand. And the distance formula allows you to work with some of these problems that we just did without having to graph them. All right, there's the distance formula. So what we're going to do is I'm just going to take the last problem we did where we were given the A and the B coordinates, and instead of plotting it on a graph, I'm just going to simply plug it in. All right, in the previous problem we were told what A was and what B was. What I'm going to do is I'm going to take the X from that one and the X from that one and plug them into those positions. Now since I chose the 2 from the 6 coordinate, the A coordinate, since I chose the 6 first to go in that first spot for the X's, I have to choose its Y to go in the first spot there as well, okay? And then the other Y comes in and fills in there, okay? The order matters in these, okay? So don't worry about large and small or anything like that. It's just simply whatever point you decide to put the X in first, you grab its Y and put it in first as well. All right, so there's the equation with the information in it. If you've lost track of where the numbers come from, go back and review that as I'm doing it. I'm just simplifying that. I end up with a -3 there, but that's no worries. Remember, when you take a -3 and you square it, it's a -3 times a -3. That becomes the 9. The two negatives cancel each other out, and it becomes a positive number. So we have AB is equal to square root of 25, which we would never leave as an answer. We'll put it as equal to 5, of course. Okay, so there's our answer right there. Very good. All right, don't forget to write your summary. And we're not quite done. We still have a couple more things. We need to do some vocabulary words. Then we have our do-it problems to expose you to. I apologize for the length of this, and you've done a great job if you made it this far. Fantastic. Let's move on. I'm sorry. Put me on pause. Do your summary, and then let the video start back up. All right, so on the last page here, we have the segment addition postulate. Basically, the segment addition postulate says that if I have 3 points, A, B, and C, and they're collinear, they fall in a line, right? And B is between it. It doesn't have to be in the midpoint or anything. It just has to be between it. And between A and C, then the segment length of AB and the segment length of BC added together have to equal the whole thing of AC. Okay? All right, so the next thing it says the measured distance between the points A and B is written as, and you have just AB. There's no line above it, anything. It says the line that contains points A and B is written as AB with the line graphic above it. And then the line segment that contains A and B looks like this with a line segment above it. Okay, that's all of our notes. Draw your line, do a summary, and hey, listen, after I scroll through the problems that are just about ready to come up, there's a bonus. So if you watched the video this far, you deserve a bonus. So take a look, walk through your do it problems, and then just stick around in the video a little bit longer to see what the bonus is. Make sure you turn the bonus in and the do it problems in on separate pieces of paper. All right, here we go. All right, there's your do it problems, and so I'll scroll it in a little bit tighter so that you can see it. And 3 simple problems. Hopefully it'll take you a little bit longer to do these problems because there's a little shorter problems, number of problems. All right, let me make it bigger and scroll through. And there you have it. All right, and here's that bonus I promised you. Put it on pause. It's going to jump off now. We're done with the video. Bye-bye.